Systems of equations pyramid puzzle. I'm just going to do two problems, C and J, with you just to show you the expectations for work. So in C, I can just automatically graph this because it's already in y equals mx plus b. So when I've got y is equal to 2x minus 1, I know I need to start at -1 on the y-axis. So I go down to -1. And then 2 is the same as 2 over 1. So that's a rise of 2, run of 1, up to right 1. For me, I like to see every single point plotted in the graph going in both directions. So you go, go, all the way down. And then we just connect it all up. So it doesn't have to be absolutely neat. You don't need to use rulers, but just especially because you're plotting all of the points in the graph itself. For the other equation, x minus 3y is equal to 18, we need to isolate it. So this is what I mean by saying show the work. When I write W on your paper, it means you're not showing work. So the work that I'm looking for, you don't have to show the minus x, but you're moving the x term over and getting negative x plus 18, and then dividing all the terms by -3. Again, you don't have to show that. You just show the final simplified form, which is y is equal to, 1/3 x minus 6. So you simplify things down. So the common mistake students make is forgetting that numerator is a 1 and simplifying down the two negatives. So positive and negative simplifies to -6. Two negatives make a positive 1/3. So I start at the -6, so down 2, 4, 6. And then I'm going up 1, right 3. And I reverse that, down 1, left 3. And I see a nice point right there where they're intersecting. So that's going to be a solution. So I'm going to delete this out when I go into my slides, and I'm going to write that ordered pair that I found. So I'm going to connect these all up. So that ordered pair looks like it's at -3, -9, is it? So nope, 7. Yeah, -3, -7. So I'm just going to write it up here. And we can do the same with J. So J is down here. I've got x plus y is equal to 10. So really the only work I need to see for that first one is that you understand that x term needs to move over to the other side by subtracting x. So you don't actually have to show that, but I do want to see the -x plus 10, y is equal to that. So that's, again, work that I want to see. So there's this part of work where you're showing this step, and then there's this part of the work where you're rewriting it in its form. If it's just one step, you just have to show that one. So -x plus 10. So this is our first negative slope. So we're going to start at positive 10, 2, 4, 6, 8, 10, all the way up at the top there, I think. 2, 4, 6, yep. And then it's -x, so I'm going down 1, right 1 now. I'm going to go all the way down. We just connect up all those points. So again, it's okay if it's not perfect because you got all the points there showing exactly where they should be crossing. And then the other equation is 4x minus y is equal to -5. So I'm just going to show it up here. 4x minus y is equal to -5. There's two ways you can solve this. I personally like the pattern of just moving the x term over and dividing by that coefficient because it's fairly consistent, and students tend to make fewer mistakes that way. But I'll show you the other way as well. So we can divide all of these by -1. And y is equal to 4x plus 5. The other way is to see that you've got 4x minus y is equal to -5. So you could actually add the y and make that into y minus 5 is equal to 4x. And then when you add the 5, you'll get 4x plus 5 is equal to y. So either way, you get the same answer. It's just a different method. So either set of work, and again, I'm just looking for those two steps or those two steps for your work on a separate paper, or you can do it on the graph paper that you that I provided you in Cami. So I'm starting at +5, and it's a positive slope, up 4, right 1, so it looks like I'm intersecting there. But again, I want to see all the points for both graphs. So we just continue going down 4, left 1. Can't go any further, so I just connect those up as best we can. And it looks like the point for this one is going to be at 1, what is that, 1, 9? Now, the way this puzzle works is that we are looking for the ordered pair below. I think we've done something sort of similar to this. Let me see if I can grab this. There you go. Oops, no, I can't. Okay, well, that's all the way over here now. The way that it works is you're going to add the x values. So these are both the x values. These are both the y values. You're adding the two x's. So -3 plus 1 gives me -2, and then -7 plus 9, adding the y's, is positive 2. So that means that whatever card has a solution of negative 2, positive 2 should go right here in this part, because that's where these 2 points are kind of meeting, these 2 cards. So that's how you tackle this question.